Okay, so last time we talked about variance and population standard deviation, what a deviation is, find the average deviation, and we worked through a population example. All right, today we're going to do a sample standard deviation. All right, so again, we come at samples different than we come at populations. This is where it's important to establish, and the problem will always tell you, find the sample standard deviation, find the population standard deviation, because the formulas are different. The outcomes are different, and what you have to find on the calculator is different. Now, we will be doing this on the calculator because I did the one example last time just to show you kind of the process, what the calculator is doing. And then my expectation is that you will solve it all on the calculator, and that's what I actually want you to do. Alright, so sample standard deviation. Again, when we do samples, we use the English letters. When we do population, it's the Greek letters. And so for sample variance, we use a capital S squared. Right? Capital S squared means the squared deviations. That's what capital S squared is, the square deviations of a sample. Alright, so again, the way it's easy to remember it is S for sample. And so it's done the same way. Up top would be the taking all of my scores, subtracting the sample mean, right? X bar is the sample mean. Squaring them, adding up all of my square deviations, that's what the summation notation is. But the difference is, if you'll notice, what I'm dividing by. So it's not a pure average. Instead of dividing by the total, what they do instead is divide by 1 minus the total. So if I had 10 deviations, if it's a sample of 10 deviations, I would only divide by 9. And what that does is there's error, right? If I'm not sampling everybody, the average isn't perfect because it's not everybody. And so the deviation's not perfect, and so they want a broader range, and to do that, the way they've corrected it, is to divide by 1 less than how many items I have. Alright, so again, if I had 10 items, I divide by 9. Now, you're not going to have to do that, it's all done in the program, but that's what's going on, and that's why the sample standard deviation is different than the population standard deviation, and sample is always a bigger deviation, because there's more error if I'm not pulling everybody, right? There's error involved. There's a bigger plus minus. And then the sample standard deviation is our capital S, which would be the square root of our variance. Alright, so again, it's the sample, it's the approximate, that's why it's a sample, average deviation from the mean. It's approximate because it's a sample. So remember, the two calc classes I had before where the average was a 73, where I pulled 10 people from each class and I found they had the same average. So it was a sample of 10 students from the classes. But they deviated differently. One class's 10 students that I picked were far up from my average, they spread far away, and the other average was closer. And so we're going to look at the two calc classes. And again, I'm going to do it on the calculator. I'm not going to show you this by hand, although the process would be identical to what we did before, except instead of dividing by n to get to the variance, I divide by n minus 1. So instead of dividing by 10, I divide by 9. But I'm not going to do that. I showed you one time, and my expectation is that you use the calculator. Actually, I want you to use the calculator because it's more accurate, right? Less things can go wrong. Alright, so, but I do have to separate these into two outcomes. So I'm going to do class 1 first, and then over here I'll do class 2. Alright, so class 1, remember, is the first list of scores here. And so this is all done in the stats key. So you do your stat, you go over to edit. There's only one list, right? You're only putting in class 1. Alright, so list 1 are going to be class 1's scores. Alright, those are the X values. So the 48 through the 100 is what's going into my calculator. After I do that, I quit. Then we'll go back into stat, over to calculate, and we're going to calculate our one variable statistics. Right, which again, there's only one list. So make sure there's no frequency. So there's only one list. Alright, so I'm going to go to my calculator and do that. So popping up a calculator here, clear what I had in before. So stats, edits, got to clear out my previous list, so clear out list 1. Oops. There we go. And then carefully type in. The biggest thing to go wrong with these is accidentally mistyping something into my calculator. So kind of double check as I go. And then the average should come out as 73, so if it doesn't, that means I must have mistyped something. Calculator's being slow today. There we go. Alright, they're in there. Quit. Go back to stats. Go over to calculate. One variable statistics. If your calculator is like mine, make sure there's nothing in the frequency. I only plugged in one list. Hit calculator. If yours is the other type of calculator where it pops up one variable stats, you're good to go. You just hit enter. Alright, you should be able to get to the same answer I do. Alright, there it pops up. It did find my average, and then if I'm looking here, what the calculator doesn't know. It doesn't know if it's a population, and it doesn't know if it's a sample. And so it errs on the side of caution. It gives you both. And so if you look down here, that SX, which is above the sigma X, it gives you both. It gives you the population standard mean and the sample standard mean. You just have to make sure you know which one you're being asked to find, and then be careful that you pull off the right one when you go to plug it in wherever you're writing your answer in. And so the sample standard deviation is the 18.844. Alright, so it's the SX, it's the sample standard deviation of the X values. And so in this particular case, it came out 18.844, or just a couple decimal places, 18.484. Which means the spread of the scores are pretty large. 18 is pretty big, right? The average was 73. The plus minus on that was an 18.84. So most scores landed between a 73 plus 18.84 to a 73 minus 18.84. Right, which most scores were between. This would be a 54.16 to a 91.84. And again, it's most scores, about 68% of the scores. And if you look, most scores land between a 58 and the 91's a little off. But it's a sample. Remember, samples are off. But majority of them, right? Most scores land in that range. Again, usually it's about 68%, a little more than half land in that range. Right, and so the guess would be if we picked another student, that's where their final exam score should land. Right, class 2, though, should have a different answer, right? Class 2's spread should be much smaller. So again, we do the same song and dance. I'm just going to plug list 1, though, is going to be my class 2 scores. There are my X values. So that's the thing I'm changing. So I'm going to go to my calculator. I'm going to clear that out. Go into stats, edits. Clear that list out. And now type in carefully. Again, the biggest thing I usually do is accidentally mistyping stuff. I get in a rush and I, mistype 70 as 71 or 80 or something like that. So again, it's just make sure you're careful when you're plugging these in. Kind of double check it as you go. Because you don't want to have to type these things out more than once. Alright, so as long as I typed them in there correctly, I quit. Go back to stats, go over to calculate, my one variable statistics, which I should be good to go. There's no frequency. And then calculate. Right, my average, oh, did I mistype something? Should have been a 73. Alright, there's a, must be nice, 68, 70, 72, 72, 73, 75, 77, 80. Oh, 68. That should be a 66. The very first number I messed up. Quit. Let's try it again. See, I told you. The worst mistake is me mistyping something on these. Calculate. Alright, but I knew the average should have come out 73, and now I've got 73. Alright, so 73 is the average, and then remember, I'm picking, and this is where, when it's small like this, the averages deviation isn't that much different than what our population would have been. But remember, we want the sample, so the S1. So if you're typing this out as an answer on WebAssign or an answer on a test, you want 3.97. You don't want 3.76. And it's very, very easy to mistype that. So double check and make sure you're careful that you pick the right one. And so we want 3. So our standard deviation for class 2 was 3.97, which is small. It's a lot smaller than the other class. The other class deviated by almost 19 points, right? Most scores were either 19 points below or 19 points above. In class 2, 4 points, right? 3.97 is only a 4-point deviation, so most scores were within 4 points of the average, right? The average for the class 2 was the 73, and the plus minus on that was 3.97. So most scores are between a 73 plus the 3.97 to the 73 minus the 3.97. So most scores landed between a 69.3 up to a 76.97. Most scores, and if you go look at that, most scores did, right? Almost all of them, only 3 of them didn't, but the 77 is pretty close to that, and the 66 was pretty close to that. So again, small range, right? If I picked another student from my class, again, based on the numbers, I would assume that they'd land somewhere in between 69 and 76. Alright, and so again, it's a small range. And so that's what the sample standard deviation is. The big thing with these deviations are, again, be careful when you plug them in the calculator, and then be careful when reading the number out, especially in something like this one where the numbers are close to the same, right? The other one they weren't close. One was a 16, one was an 18. This one, however, they're close though. They're just off by a few tenths, right? 3.79 and 3.76. So if it's sample, you've got to make sure you pick the 3.79. Usually they'll have you around 2 or 3 decimal places, so they make sure that they've got the right one. Alright, so again, be very careful on these. Right, so I'll stop there. The next one we're going to look at are going to be doing these same things with frequency tables. Alright, so frequency tables in the next video.